Eric Schmidt takes the helm, aiming for orbital success with Relativity Space's Terran R rocket by 2026. On March 10, 2025, it was officially announced that Eric Schmidt, the former CEO of Google, has become the new chief executive of Relativity Space, a strategic move expected to bolster the company's efforts in the highly competitive launch vehicle market. Schmidt's appointment is pivotal as Relativity aims for its Terran R rocket's first flight slated for late 2026. Background of the appointment. Eric Schmidt, who led Google from 2001 to 2011 and served as executive chairman until 2017, has a significant personal stake in Relativity Space, reportedly involving a substantial investment, though specific figures remain undisclosed. Schmidt replaces Tim Ellis, a co-founder of Relativity and its previous CEO, who will continue to serve on the board. Ellis's departure marks a transition for the company, especially after the setback of the Terran R rocket, which failed to reach orbit during its inaugural launch in March 2023. The Terran R development. Relativity Space has made considerable progress in developing the Terran R, a fully reusable rocket designed to compete with industry giants like SpaceX. The company has completed a critical design review and begun the production of flight hardware, including panels for the first and second stages. The Aeon R engine, specifically designed for the Terran R, is also under development, with successful hotfire tests exceeding 2,500 seconds, showcasing the engine's capabilities. Market demand and economic context. Relativity Space is strategically positioned to meet a growing demand for cost-effective launch services, evidenced by a backlog of orders valued at $2.9 billion for the Terran R. This demand reflects a broader market need for diverse launch options, particularly in the wake of SpaceX's dominance. Josh Brost, Relativity's chief revenue officer, emphasized that the Terran R is designed to fulfill the requirements of low Earth orbit LEO constellations, making it an attractive option for customers seeking reliable and economical launch services. Strategic vision under Schmidt's leadership. Under Schmidt's leadership, Relativity Space is expected to refine its strategic vision by leveraging advanced manufacturing techniques, including 3D printing. The company's goal is to streamline production processes and reduce costs, thus positioning the Terran R as a competitive alternative in a market that increasingly seeks additional launch providers. The timeline set for the first launch in late 2026 aligns with Relativity's broader mission to innovate within the aerospace sector. Key points from various sources. A consensus among sources highlights Schmidt's extensive background in technology and the significance of his appointment as a turning point for Relativity Space. The shift from the Terran R to the more ambitious Terran R is emphasized, alongside the technological advancements being made and the substantial order backlog that reflects robust market demand. While some sources detail the technical aspects of the Terran R's development and its financial implications, others provide a more general overview of Schmidt's appointment without delving deeply into specifics. The emphasis on Schmidt's strategic importance and the company's innovative approach to manufacturing remains consistent across reports. Conclusion. In summary, Eric Schmidt's leadership marks a crucial moment for Relativity Space as it aims to navigate the competitive launch vehicle landscape. With innovative technology and a growing demand for diversified launch services, the company is well positioned for success as it prepares for the Terran R's debut flight in 2026. Schmidt's involvement is not only strategic from a business perspective but also symbolizes a renewed commitment to pushing the boundaries of aerospace innovation. The appointment of Eric Schmidt as the CEO of Relativity Space might seem straightforward, but it reveals several counterintuitive insights about the dynamics of the aerospace industry and the strategy of Relativity Space moving forward. 1. Executive experience versus industry expertise. Schmidt's background as a tech executive at Google could be perceived as an asset for a space company. However, the aerospace sector often requires a different set of competencies, including deep technical knowledge of rocket engineering and launch operations. While Schmidt brings significant leadership experience and a network of contacts, His lack of direct experience in aerospace could raise questions about his ability to navigate the specific challenges of rocket development and launch services. This contrasts with many industry leaders who have backgrounds rooted in aerospace engineering or operations, highlighting a potential disconnect between traditional industry expertise and tech-driven leadership approaches. 2. Investment versus operational control. Schmidt's substantial financial investment in Relativity, coupled with his new role as CEO, suggests a strong personal commitment to the company's success. However, this situation poses a potential risk. The conflation of investment with operational control can lead to conflicts between strategic vision and financial interests. This counterintuitive dynamic suggests that a CEO's decisions might be influenced more by the desire to protect personal investments rather than the broader interests of the company or its stakeholders. It raises the question of whether Schmidt's leadership will focus on innovation and risk-taking or whether he will prioritize short-term financial stability. 3. Shifting focus from Terran 1 to Terran R. The decision to pivot from the Terran 1 to the Terran R is strategic but also highlights a counterintuitive aspect of product development in aerospace. Typically, companies invest heavily in refining their initial products before moving on to new designs. However, Relativity's quick abandonment of the Terran 1 after a failed launch suggests a willingness to prioritize a more ambitious project over iterating on an existing product. This could be interpreted as a signal of confidence, but it also raises concerns about resource allocation and the potential for overextending the company's capabilities in a highly competitive market. For market demand versus competition, the $2.9 billion backlog of orders for the Terran R indicates a strong market demand for alternative launch services, especially in the context of SpaceX's dominance. However, the very existence of this backlog could be misleading. It implies a robust demand, but it may also reflect a market desperate for options rather than a sustainable competitive advantage for Relativity. The aerospace industry is notorious for its long development cycles and the potential for delays, which means that a backlog does not guarantee successful launches or profitability. This counterintuitive notion highlights the tenuous nature of market signals in a sector where demand can fluctuate dramatically based on technological advancements and competitive dynamics. 5. 3D printing as a game-changer. Relativity Space's reliance on additive manufacturing. 3D printing is presented as a revolutionary approach to rocket production. While this technique does offer potential cost savings and flexibility, it also introduces unpredictability into the development process. The counterintuitive aspect here is that while 3D printing can streamline production, it may also lead to challenges in quality control and reliability, critical factors in aerospace engineering. The belief that innovative manufacturing methods alone can disrupt established players like SpaceX may overlook the complexities of ensuring safety and performance in rocket launches. 6. Long-term vision versus immediate execution. Schmidt's appointment and the ambitious timeline for the Terran R's first flight by late 2026 suggest a focus on long-term goals. However, the aerospace industry is often characterized by unpredictable timelines and unforeseen technical challenges. The pressure to meet ambitious deadlines can result in compromises in safety and quality, leading to potential failures. This counterintuitive tension between a visionary timeline and the realities of engineering challenges could pose significant risks to Relativity's reputation and operational success. 7. Public perception versus reality of progress. The narrative surrounding Schmidt's appointment and the progress of the Terran R may create a perception of rapid advancement and potential success. However, the reality of the situation may be more complex. Public announcements often highlight achievements while downplaying setbacks or challenges. The juxtaposition of a high-profile leadership change with a significant backlog and ambitious development goals can create an optimistic outlook, but this may not accurately reflect the internal challenges the company faces. The counterintuitive understanding is that while public perception plays a crucial role in investor confidence and market positioning, the actual path to achieving these goals is fraught with risks and uncertainties. In conclusion, While Eric Schmidt's leadership at Relativity Space is framed as a strategic move to enhance competitiveness in the aerospace sector, several counterintuitive elements exist within this narrative. These include the complexities of leadership dynamics, the interplay of market demand and competition, and the inherent unpredictability of developing innovative aerospace technologies. Understanding these nuances is crucial for stakeholders and observers as Relativity Space aims for success with its Terran R rocket. In the report regarding Eric Schmidt's appointment as CEO of Relativity Space, several key points might be overlooked by many readers, particularly those not deeply involved in the aerospace industry or technological innovation. Here are the overlooked elements, along with their significance. 1. Shift from Terran 1 to Terran R. The transition from the failed Terran 1 rocket to the more ambitious Terran R is a significant shift that underscores Relativity Space's commitment to innovation and resilience in the face of setbacks. The failure of Terran 1, which did not reach orbit during its inaugural launch in March 2023, could be seen as a critical moment for the company. However, the decision to pivot towards the Terran R, a fully reusable rocket, shows a willingness to learn from past failures and adapt to market demands. This strategic redirection is essential, as it positions Relativity to compete not just with emerging companies but also with established players like SpaceX. The significance lies in the company's ability to innovate and its potential to disrupt the status quo in the launch services market. 2. Eric Schmidt's investment and industry connections. Schmidt's substantial investment in Relativity Space, while lacking specific figures, is a noteworthy aspect of his appointment. His financial stake indicates a strong personal commitment to the company's success, which could bolster investor confidence and attract further investment. Moreover, Schmidt's extensive network and experience at Google provide unique opportunities for strategic partnerships and technological synergies that may not be readily available to other companies in the aerospace sector. His role could facilitate access to advanced technologies and data analytics capabilities that enhance the development of the Terran R, thereby improving its competitiveness. 3. Manufacturing innovations. Relativity's reliance on additive manufacturing, 3D printing, is a critical component of its business model that is often overshadowed by discussions of launch capabilities. This approach allows for rapid prototyping and reduced production costs, enabling the company to pivot quickly in response to market needs. The ability to print rocket components on demand could revolutionize the aerospace industry by significantly shortening the time between design and production, allowing for a more agile response to customer requirements. This innovation is significant not just for Relativity but also sets a precedent for the industry, potentially influencing how rockets are designed and manufactured in the future. 4. Market demand and competitive landscape. The $2.9 billion backlog of orders for the Terran R is a crucial indicator of market demand that may be underestimated. This backlog reflects a significant validation of the company's offerings and highlights the need for more diverse and cost-effective launch options beyond the current dominant player, SpaceX. The significance here is twofold. First, it showcases a strong market appetite for additional launch providers, which could lead to a more competitive landscape and potentially lower launch costs for customers. Second, it emphasizes the industry's growing recognition of the importance of reliability and cost-effectiveness in launch services, which is essential for the proliferation of satellite constellations and space exploration missions. 5. Long-term vision and strategic goals. Schmidt's leadership is poised to enhance the strategic vision of Relativity Space, particularly regarding its focus on advanced manufacturing and cost reduction. The emphasis on streamlining production processes is crucial in a sector where margins can be tight and competition fierce. Under Schmidt's guidance, the company could prioritize not just immediate launch capabilities but also long-term sustainability and innovation, ensuring that it remains relevant in a rapidly evolving industry. The potential for increased efficiency and reduced costs could lead to a paradigm shift in how space missions are planned and executed, making space more accessible for a broader range of organizations, including smaller startups and international players. 6. Potential for technological synergies. Schmidt's background in technology and innovation could lead to collaborations that integrate cutting-edge technologies into Relativity's operations. His experience with artificial intelligence data analytics and software development at Google may pave the way for advancements in mission planning, rocket design, and operational efficiency. The significance of this potential cannot be overstated. Leveraging technology could enhance the reliability and performance of the Terran R, making it a more attractive option for customers looking for dependable launch services. In conclusion, while many reports will focus on the surface-level details of Schmidt's appointment and the Terran R's development, the underlying implications of these changes are profound. The shift in strategy, investment in innovation, reliance on advanced manufacturing, and strong market demand collectively position Relativity Space as a significant player in the aerospace industry. Understanding these nuances can provide deeper insights into the company's potential trajectory and the broader implications for the space launch market. 1. Leadership transition and strategic vision. Eric Schmidt's appointment as CEO of Relativity Space marks a significant shift in leadership. Moving from co-founder Tim Ellis to a figure with extensive experience in technology and innovation. Schmidt's background at Google and his considerable investment in Relativity underscore a strategic vision aimed at leveraging advanced technology and industry connections to enhance the company's position in the competitive launch vehicle market. This transition suggests a potential for transformative changes within Relativity aligned with Schmidt's track record of fostering innovation and growth in the tech sector. 2. Development of the Terran R rocket. The Terran R represents a critical advancement for Relativity Space, shifting focus from the unsuccessful Terran 1 to a fully reusable rocket designed to compete with industry leaders like SpaceX. The completion of a critical design review and the initiation of flight hardware production signify tangible progress. Furthermore, the development of the Terran R engine, which has undergone successful testing, indicates that Relativity is on a promising path toward delivering a commercially competitive launch vehicle specifically targeting the burgeoning demand for low Earth orbit LEO services. 3. Market demand and financial backing. Relativity Space's impressive backlog of $2.9 billion in orders for the Terran R highlights a robust market demand for diverse launch options, particularly as customers seek alternatives to SpaceX's dominance. This financial backing reflects confidence in the company's ability to meet the growing needs of the aerospace sector, especially for LEO constellations. The acknowledgement of the urgent demand for cost-effective launch services positions Relativity as a key player in addressing market gaps, which is crucial for its success in the competitive landscape. 4. Technological innovation through advanced manufacturing. Relativity's commitment to utilizing advanced manufacturing techniques, particularly 3D printing, sets it apart from traditional aerospace manufacturers. This approach not only aims to streamline production and reduce costs but also enhances flexibility in manufacturing processes. The strategic focus on innovative technologies aligns with the company's mission to redefine the aerospace sector and positions the Terran R as a distinctive offering in a market that increasingly values efficiency and adaptability. Schmidt's leadership is expected to drive further advancements in this area, potentially revolutionizing the launch vehicle industry. 1. Howard Hughes and the H-4 Hercules Spruce Goose. Howard Hughes, an aviation pioneer and billionaire, led the development of the H-4 Hercules, also known as the Spruce Goose, during World War II. Hughes took personal control of the project, which aimed to create a massive flying boat to transport troops and supplies. Despite numerous challenges, including engineering difficulties and resource limitations, Hughes pushed forward, showcasing his vision and determination. The aircraft was completed in 1947 and famously flew once, though it never entered production. Hughes' leadership and the ambitious nature of the project mirrored Schmidt's appointment at Relativity Space, highlighting the influence of visionary leaders in aerospace innovation. 2. Elon Musk and SpaceX's Falcon 1. Elon Musk founded SpaceX in 2002 with the goal of reducing space transportation costs to enable the colonization of Mars. The Falcon 1 rocket, SpaceX's first orbital launch vehicle, faced multiple setbacks, including 3 failed launch attempts between 2006 and 2008. Musk's relentless commitment and personal investment were crucial in overcoming these challenges. The fourth launch in 2008 was successful, marking a turning point for the company. Musk's journey reflects Schmidt's current role at Relativity, as both leaders have faced initial failures but remained committed to their visions, ultimately resulting in groundbreaking advancements in rocket technology. 3. Jeff Bezos and Blue Origin's New Shepard. Jeff Bezos founded Blue Origin in 2000 with the aim of making space travel more accessible. The New Shepard suborbital vehicle was developed to carry tourists and research payloads to the edge of space. Early tests faced difficulties, but with Bezos at the helm, Blue Origin prioritized safety and incremental improvements. After several successful test flights, New Shepard achieved its first crewed flight in July 2021. Bezos's strategic approach and commitment to long-term goals resonate with Schmidt's plans for Relativity Space, underscoring the importance of perseverance and innovation in the competitive space industry. Future outlook: predictions for Relativity Space and the Terran R rocket. As Eric Schmidt steps into the role of CEO at Relativity Space, the company is poised for significant advancements in the aerospace sector. Key predictions for the future of Relativity Space and the Terran R rocket program by 2025 include the following. 1. Successful first flight by late 2026. With a strong focus on the Terran R rocket, we can anticipate the successful first flight by late 2026. The company's commitment to rigorous development processes, including the recent completion of a critical design review and the progress on engine tests, suggests they will meet this timeline. The emphasis on reusability will also become a pivotal selling point in the competitive launch vehicle market. 2. Increased market share and customer demand. Given the $2.9 billion backlog of orders for Terran R, it is expected that Relativity Space will capture a significant market share, especially from customers seeking alternatives to SpaceX. The demand for cost-effective launch solutions is projected to grow, driven by the increasing number of satellite constellations and commercial space endeavors. As companies look to diversify their launch options, Relativity's innovative approach is likely to attract a broader client base. 3. Technological advancements in 3D printing. Relativity Space's commitment to additive manufacturing will likely yield breakthroughs in production efficiency and cost reduction. By leveraging advanced 3D printing techniques, the company could revolutionize how rockets are built, reducing lead times and allowing for rapid iteration on designs. This technological edge may also lead to partnerships with other aerospace companies seeking to adopt similar manufacturing techniques. 4. Strategic partnerships and collaborations. Under Schmidt's leadership, Relativity Space is expected to form strategic partnerships with other tech giants and aerospace companies. These collaborations could enhance the technological capabilities of the Terran R while also expanding market reach. Potential partnerships with satellite companies could see bundled offerings of launch services and satellite deployment, further solidifying Relativity's position in the market. 5. Increased investment in funding opportunities. Schmidt's background in the tech industry is likely to attract further investment into Relativity Space. His connections and reputation may facilitate additional funding rounds, granting the company the financial resources necessary to accelerate the Terran R's development and enhance its capabilities. This influx of capital could also support broader research initiatives and innovations within the company. 6. Focus on sustainability and environmental practices. As the space industry faces increasing scrutiny regarding its environmental impact, Relativity Space may prioritize sustainability in its operations. By focusing on eco-friendly practices within its manufacturing processes and launch operations, Relativity could position itself as a leader in sustainable aerospace solutions, appealing to environmentally conscious customers and investors alike. 7. Regulatory and compliance adaptations. As the aerospace sector evolves, Relativity Space will need to navigate complex regulatory frameworks governing space launches. The company is likely to invest in compliance strategies to streamline its operations and address any regulatory challenges that arise. This focus on regulatory readiness could enhance customer confidence and operational efficiency. 8. Impact of global competition. The competitive landscape in the space launch industry is expected to intensify with new players emerging and existing companies enhancing their offerings. Relativity Space will need to remain agile and responsive to shifts in market dynamics. Continuous innovation and a robust marketing strategy will be crucial in maintaining a competitive edge against established players including SpaceX and Blue Origin. 9. Growth in commercial and government contracts. As the demand for satellite launches grows, both commercial and government contracts are likely to increase. Relativity Space may actively pursue contracts with government agencies including NASA and the Department of Defense, as these entities seek reliable and cost-effective launch options for their missions. As the company demonstrates successful flight capabilities, confidence in its services will likely lead to an uptick in government engagements. 10. Expansion of production facilities. To support the anticipated increase in launch frequency and production scale, Relativity Space may expand its manufacturing facilities. This growth could be critical in meeting demand while reducing turnaround times for rocket production. Strategic investments in infrastructure will be necessary to sustain the projected growth trajectory. In conclusion, the future outlook for Relativity Space under Schmidt's leadership is promising. With an emphasis on innovation, strategic partnerships, and a commitment to addressing market demands, the company is well positioned to become a significant player in the aerospace industry by 2025. The successful implementation of these strategies will be vital as the company navigates the challenges and opportunities within the evolving landscape of space exploration and commercial launches.